Hi and welcome to the Microsoft Virtual Academy session on Software Development Fundamentals. My name is Jerry O'Brien, a technical CDM here at Microsoft, and my co-presenter today is Mr. Paul Party.
Hi, I'm Paul. I'm a content development lead at Microsoft.
What we're going to start covering in this module is module number 3, and we're going to focus on object-oriented programming. In today's world of software development, object-oriented programming is pretty much what most developers are doing, helping us to model real-world objects in our software applications. So it's a really important concept for you to grasp, and it's a rather deep subject, so we can focus on a lot of concepts in object-oriented programming. This session, we've got about 50 minutes to give you a general overview of what it is, so we won't delve too deeply, but we will cover some very specific aspects of it, and we'll take a look at the fundamentals of classes. We'll kind of describe a little bit about what a class is, how you create one in code. We'll talk about what the term encapsulation means in terms of object-oriented programming. We'll give you an introduction to inheritance and why that's important for object-oriented programming. And then we'll talk a little bit about polymorphism. And we'll demonstrate these through the use of code to give you an idea of how they all fit within the object-oriented programming world. We won't spend a lot of time about design considerations for your classes because, again, we can go quite easily spend an entire 5 days of a classroom-based training focusing on object-oriented principles. Here, this is designed to prepare you for the MTA exam. We have a Microsoft Technology Associate Exam 98-361 that focuses on the conceptual components of software development fundamentals. And so this is what we'll cover is at a conceptual level and giving you some concrete examples within the code itself.
Jerry, what does object-oriented programming contrast with? What other types of programming models are there?
So we have other different kinds of programming models. In the past, we used to program in what was considered either structured programming, which was the term it was commonly referred to as. And structured programming is more along the lines of writing code that is very specifically structured, divided up in discrete pieces of functionality, such as a method that does this and another method that does something else, and our code would call those specific methods to do all of the processing that the application required. And in trying to create applications that modeled real-world scenarios, structured programming was a little more difficult to implement because there wasn't a way of representing the objects in your code that you were working with. And prior to that, we were even doing just really basically top-down sequential programming, where code started at the top of the window in the first code instruction and executed step down all the way through to the end. So object-oriented programming is a paradigm, or it's a model that allows us to get more close to creating the attributes and the behaviors of the items that we want to function within our code itself. So that's essentially the difference between the other programming models. All right. So let's have a look at the fundamentals of classes. This will be the first section that we'll take a look at here. And fundamentals of classes allow us to focus on what a class is, how we potentially use them in our code and within our programs. And then we'll see a demo on how to create them as well. But the fundamental aspects give us an idea of how we apply the real-world aspects of an object into the coding environment itself. So we can consider a class in our program sort of like a blueprint, if you will. Or I call them a blueprint. It could be a blueprint for a house. It could be a blueprint for an automobile or a part that we're going to manufacture. And if you consider looking at it from the perspective of calling a class a blueprint, it's the same as saying if we want to build a house, we're going to have an architect draw up a blueprint. And the blueprint has very specific information about what that house is going to look like. The number of windows, the size of the house, how it's going to be constructed, what it'll basically look like. Again, taking a look at maybe a blueprint for a car, it would determine what the car model would look like specifically. So it could be the color of the car, how many wheels it's going to have, how many doors it will have, where the windows are going to position. But also more importantly is it also tells us from a different perspective of what kind of behaviors, if you will, that car is going to have. So the car can accelerate, it can brake, it can steer. Those are important aspects of the car itself. So when we talk about a class as a blueprint, that's what we're referring to, in that we're creating the blueprint or the mapping of what this object is going to look like in code. Now, it's also important to note that we have a term called objects, and when we create objects, those are a representation of that class in code. The difference between the two is, the reason I mentioned classes like a blueprint, you cannot live in the concept of the blueprint of a house, but you can live in the house itself, and the house becomes an instance created from that blueprint. So the class is the blueprint, you can't live in the class, but the object is an instance of that blueprint or an instance of that house, and you can live in that house. Using the car analogy as well, the design or the blueprint for the car, you can't drive that, but you can drive an instance of that car. So that's the subtle difference between a class and an object, and you'll see, you'll use those concepts as you start creating classes and instantiating or creating objects of those in your code. The important thing to note about too is when we create a class file is it includes all of the data, or what we refer to as the attributes, and it includes all of the behaviors of that specific class or that object in our code itself. So the data becomes the defining characteristics, and I talked about in the car, the color of the car, how many doors it has, how many windows and what size the windows are. Those are data or attributes of the class itself. And the behaviors are more about what that object is capable of doing. Let's switch to our slide here and we can see an example of a class that we've called animal. And the attributes are the type, the weight, and the color. And we'll represent this in code in the demo shortly. But that is considered the data or the attribute of that particular animal class. It has a type, it has a weight, it has a color, and I'm sure you could come up with a number of other types of attributes that you want to associate with a particular animal. But then we have a couple of other items on here called make noise and move. Those are examples of the behavior of the animal class. So animals can make a noise. A cat's going to meow, a dog's going to bark. Consider humans as animals if you want to, and we talk. So that's a way of making noise. That's a behavior that we have. And also move. So animals, are not typically going to stand in one spot, so they have the ability to move. Once again, you can probably come up with a lot of other behavior patterns that an animal could do, like eating, for example, if you will, and other things that you want to add to it. We're just going to try to keep it simple from this perspective, just to allow you to gain a good understanding of what a class and an object is through simple implementations. So,
if I can interrupt, Jerry, would it be correct to say that for those viewers who watched the previous module, Module 2, was it Module 2? Yeah.
Yes.
Where we talked about variables, constants, and algorithms, would it be correct to say that a class is just a collection of variables, constants, and algorithms? It's just essentially it wraps those up so that you can reproduce those, duplicate them, and then use them over and over again?
Yeah, exactly. So if you take a look at it from that perspective, when we create the class, the attributes or the data that we'll store in the class will be represented through variables and through constants. And we could create data structures within it to represent collections of pieces of data that will actually be represented as well. In the previous modules, as we talked about demonstrating our repetition structure, which was a good example, where we demonstrated recursion, we actually called a method, and that method is an example of the behavior. We would implement that in code to say what we wanted that object to do. And another way of looking at it too is to think about, most people are familiar with automated teller machines, so banking machines when you go to make a deposits. There are certain behaviors that banking machine has that you would expect of it. You would expect it to allow you to log in, allow you to make a deposit, allow you to make a withdrawal, transfer between accounts, or even to check your balance. That's an example of behaviors, and that's functionality you would have to write in your code to make that work within that class itself. So again, it's very important to think about the fundamentals of class as being data and behavior all in one, which brings us to the next point. So we flip over to our slide, we can see that creating that data and behavior as a part of the class is something known as encapsulation. But encapsulation in object-oriented programming terms is a little bit more than that as well, because not only do we include the data and the behavior, but it gives us, by using the encapsulation theory and concepts, we can actually hide data from the user. And in this case, the user is not the person using your program, although it could be, but it's more the user becomes yourself or another programmer who's using that class or that object in code. We create something that's known as a black box, and the black box is a term that comes from the days of people creating their own little home projects in electronics. in which case, you go to your local Radio Shack and you pick up a printed circuit board and you pick up a bunch of little electronic components. You bring them home and you assemble them all together to make something. One of the first projects I did way back in high school was an automatic headlight reminder. And what it was designed to do is you'd hook it up in your car, and if you turned the ignition off and forgot to turn the headlights off, it made a beeping sound. So it was kind of neat. It was this little project that I created, but in order to put it in a container, you would also buy an actual little black box. That is what your container, what your components actually sat into. And the concept of black box basically means that users can take your automatic headlight reminder and they can use it without knowing how it does what it does inside. That's kind of the concept of a black box. It's just, look at the stereo in your car. You get into your car and you turn the thing on and you adjust the volume by rotating the knob, and you can hit your favorites button and program in all of your different stations. You don't have a clue what's taking place in that radio behind the scenes, and you don't have to know. You're interacting with it through these components, which are known as the interface. And so encapsulation allows us to create this functionality, but yet hide it so that other people don't really need to see what it is that it's doing, which means they can't manipulate what it's doing. But it also means that they don't take and try to guess at, if I call this method to do X in that class, is there something that I need to know about that method? Well, no, it's not. The interface or their accessibility to this class simply says, I have this method called move, and you don't need to do anything but just call it, and I'll take care of everything behind the scenes. So that's an important aspect of encapsulation, is that a lot of that is actually hidden. The other thing that we focus on from that encapsulation perspective is it allows us to, when we talk about the behavior and the data hidden from the user, we can control what they do with that data. So we, in the demo, we'll see that we've got a few variables for this animal class that we declare as private, so we hide them from the user, meaning that they can't set the values in those directly. They have to use our programming interface to set the values and retrieve the values, and that gives us much better control over the data that users pass in and the data that they get back into their system. So let's go ahead and take a look at what a simple class looks like in code. We'll switch over here to Visual Studio, and what we've done here is actually modeled that animal class that we had on the slide, and we've written it in code. So we have the name animal as the name of the class, and we have things known as member variables. Again, we talked about the data or the attributes. That's precisely what these are. So we've implemented color, a weight, and a type. We've implemented data types. So as Paul alluded to a little bit earlier, are we storing these variables? And yes, we are. So the class is encapsulating that data, and we're doing so by creating data types or the variable data types within it. So we have a couple of string values and we have a numeric value that's double. Notice these keywords private, and this is where I talked a little bit about that encapsulation. We're making these private, which means that if somebody were to use my animal class in code, they would not be able to set the value for color, weight, or type directly by simply saying, I want to change the value for type. Instead, what they do is they use something called a property, and this is our interface, if you will, for setting and getting these specific private member variables. Notice that it's kind of a code convention. It's not required. It's just the way that we do this. But my first type is, or first data attribute is known as type. Notice it has a lowercase. Some folks prefer to use an underscore, so they might prefix that with an underscore. Again, it's a coding choice. It's syntax for the code itself. But the property to access it starts with an uppercase T. And again, it's not required. We can call this property whatever we want to call it, but it makes it easier for you to read. It's code readability when you do things like this. If you see the uppercase T, you know that it's a property. If you see the lowercase t in the code, you know that it's the actual data variable that we're storing. Within each of the properties, we have something called a getter and a setter. So the get keyword means I want to retrieve the value, and the return statement simply sends that back. Notice it's sending back the lowercase t, which means it's sending back the value from here. The setter, using the keyword set, takes a generic value coming in, and the keyword value is something that C# uses in its property methods that says this is the value that somebody has passed in to set what the type is. And so we assign to the lowercase type, so the member variable type here, whatever the user has passed in.
And isn't it true, Jerry, that the property actually doesn't store any data? It's the variable that stores the data, and the property is the way to access that data.
That's correct. Yeah, the property is simply a way of gaining access to the variable for either setting it or retrieving it, and the actual data storage itself is stored in this local variable up here. Okay, so it becomes a local variable for that. We call them instance variables because it's specific to the class that we create, or sorry, specific to the object that we create. So yeah, no storage takes place in here at all. We also have the ability to say that, you know what, some of these properties are read-only. In other words, you can't set the value. We've set it in code, and in which case what we would do is just simply not include that setter. So you would only have a get in here. Likewise, we can remove the get and simply have a set. So we can make something write-only versus read-only or versus read-write. All right. So we have in here a getter and setter or a property for type, for the weight, and for the color of our animal. Now, we also talked about some behavior. So here's the behavior that we were focusing on. We have a couple of what are known as instance methods. So we have one called make noise and we have one called move. Now these are relatively simple. All they're going to do is output to a console window some text based on when the user calls it. So if we were to call animal.makeNoise, we would see printed out on the screen, animal is making noise. If we were to call move, then we would simply print out on the screen, animal is moving. So again, that's just a quick and simple representation of creating a class in code. And this is an animal class like we had on the screen on the slide deck momentarily ago. And we have our member variables known as the data or the describing attributes. And we have ways of getting and setting them, which are create the encapsulation or that data hiding for us, allowing us to control access to it. And then we have the functionality such as make noise and move.
And that public keyword is what makes those an interface so that users can actually get at the properties and the methods.
Yeah, good point, and that's exactly correct in that if you see a keyword public, and again this is the C# syntax, other programming languages use similar, but the word might be a little bit different, but it does, that's what allows the other programmers or your program code to gain access to these is because they're public as opposed to private. Okay, so that was, again, a quick and simple look at creating a class. And the next thing we talked about was the concept of inheritance in object-oriented programming. And inheritance is exactly what the word sounds like if you're familiar with it from thinking about things you inherit from your family. Now, we're not talking about, you know, you inheriting $1 million from your grandfather when he passes away. What we're referring to here is attribute and behavior inheritance. And if you take a look at the color of your eyes, the color of your hair, and some of your mannerisms, the way you speak, the way you do certain things, those are typically inherited from a parent, from a grandparent, right? And classes kind of function the same way. So when we talk about the inheritance in object-oriented programming, the data, which is the attributes, and the behavior are taken from another class. This creates the concept of what we refer to as superclasses and subclasses, or base class and a derived class. There's different terms that you can use for it, but a superclass or a base class becomes sort of the parent, and the derived class or subclass becomes the class that does the inheriting. It's the one that collects those values from the parent class or from the superclass. And what it does is by creating or by supporting inheritance, it allows the programmer, it allows you to create a common base class that has functionality that would be common across a bunch of different subclasses and allows for code reuse. So you would create this basic functionality. In our example, the animal class, we chose, there's a type of an animal, the animal has a color and it has a weight, and it has two methods called make noise and move. And make noise and move were very generic because we don't know what kind of animal it is that we might create. We can use inheritance and start creating different types of animals such as a dog or a cat or a horse, and we can inherit those characteristics from the animal class because a dog is an animal and a horse is an animal. So they have common traits, and this is where the inheritance comes into play, in that we create that base class or that superclass with the common aspects, functionality and attributes, and then we can reuse those in our other classes that become subclasses, and we don't have to write that code again. We'll see that in the example here in just a minute when we talk about demonstrating how we do inheritance within the code itself. So, having said that, let's look at what inheritance looks like in the code. So again, here's our animal class. This is what we just looked at. We created this as with the thought in mind that this would become a base class or a superclass. Then we also created this thing called a dog class. Now, just so you know, there's no smoke and mirrors here. All of the implementation that I have for my dog class is commented out. That's what the green text means. That's what these two forward slashes mean in C#, is it's commenting this code out. As far as the compiler is concerned, this code doesn't exist. It's just textual information for me to read. But I wanted to show you that the dog class has nothing written in it. So in essence, the dog class should not be able to demonstrate functionality or attributes. But it can, and it does so because I have said I want my dog to inherit from the animal class. And that's what this colon and the animal word is doing here in this particular line of code. This is C#'s syntax. I find that very hard to say fast, C# syntax. But this is the way C# handles inheritance, is it says, give me the name of the class you're going to create, put a colon in there, and tell me the class you want to inherit from. So the reason why I did it this way and commented everything out in dog was because what I wanted to show you was as we start to implement this in code, now we're going to use a feature that is present in Visual Studio that's known as IntelliSense. And IntelliSense in Visual Studio provides functionality for us that makes our coding job so much easier. Once you get used to this, you're not going to want to code in an environment that doesn't have this, because it adds in functionality in the integrated development environment of Visual Studio that lets you pick and choose attributes and functionality from code without you having to remember what all it was that particular piece of, in this case, what the class actually has available to it. As an example, let's go ahead and create a new dog here for a second. So I'll go dog, and we'll call him Spot, and we'll say equals new dog. And this is the syntax for instantiating an object of the dog class. So this is what we refer to in object-oriented programming as instantiation. The dog is the blueprint. Spot is the instance of a dog that I have decided to create in my code. So we have a dog now called Spot, and you can consider Spot as your dog running around your living room as opposed to the generic dog when you think of a dog as an animal type. And so now what we do is we say, okay, I want to access some of the attributes of the functionality of the dog. So my instance is called Spot. So I say Spot dot, and here's that IntelliSense in action. So it pops up this little dialog box in the middle that lists all of the functionality available to my dog object. You'll notice that we have color, make noise, move, type, and wait. But I did not create those in my dog class. I created those, remember, in my animal class. Type, weight, color, and our methods down here. Dog actually has access to them because we said it inherits functionality and attributes from animal. This is inheritance in action, okay? So I have the ability in my program to say spot.color equals brown. So I've just given my dog a color, but my dog doesn't implement anything to do with the color attribute. It's available in the dog class because my dog is a type of animal, right? So again, that gives you an example of inheritance in action. We also said we wanted to talk a little bit about polymorphism, and this is another key aspect of object-oriented programming. If you break the word down, poly means many, multiple. So we can have multiple of something, and morph means to change. So essentially, polymorphism means that we can have multiple versions, different versions of the same thing. What does that mean in our classes? Well, polymorphism basically means a behavior change or an attribute change. That's what we're referring to. We've already seen how we created the base class of an animal, And we've seen how we inherited the behavior and the functionality and attributes from the animal class into our dog class, but we can also make changes to our dog class that suits what we want it to do. And as an example, let's go ahead and do a quick demo of polymorphism itself. So we'll switch back over to Visual Studio. And let's go back in and look at our dog class again for a second. And now here's where we'll start implementing some of that polymorphic behavior, if you will. We know that a dog has the ability to have attributes that might be slightly different from an animal. And in that case, we have something called a breed. So if we were to uncomment this code so that it becomes a part of our class, our dog class now actually has a breed. And if we come back into, actually it's a good idea just to quickly say between them so that the program knows about the changes. If I come back and I say spot dot, notice that I have now added breed. Where it wasn't there before, breed is there now. So I've now actually changed my attributes of my dog class to be different from the animal class. Animal does not have breed, although it could have, but in this instance it doesn't. But dog has. So I can set the breed to, you know, German Shepherd, Chihuahua, whatever. So this is customizing my dog class to what I want it to be, how I want it to function.
And if you instantiated animal, animal would not have breed, but dog would.
That is correct, and that's a good point, Paul. So if we come back and we said I wanted to create a new animal class called myAnimal, and we create a new animal class, and we come back in and we say myAnimal dot, all we see is what the animal implements. So it implements, you know, color, make, noise, move, type, and weight, but it didn't implement the breed that our dog class actually has, right? So that's an important distinction to make, in that when we do implement polymorphism and we change our subclasses, we do not change the superclass, okay? We're not impacting that at all. Now, polymorphism also provides us with the ability to change functionality. And here's an example of adding a new method to the dog class, again, that animal didn't have. It's called wagtail. And, you know, we could put in our console.writeLine here, which is, you know, our implementation of saying, you know, dog wags tail. And oops, that adds the functionality for the dog. Animal doesn't have a wagtail method. But here's an interesting aspect of how polymorphism comes into play, and different programming languages will implement this slightly differently. But we have something here called public override void make noise. And if you remember from our animal class, we did have that method called make noise, okay? And we declared it as a virtual method. This is the way C# handles our polymorphism and the ability to change things, is we can create virtual methods. Virtual methods can be overridden in a subclass, and that basically means that we can change what that behavior is. If we go back and we look at the dog class, we can see that we've changed here and we've said, you know, console.writeLine bark. So this is a change in the make noise behavior that we want our dog to do. So the dog has a specific noise that it makes, whereas an animal has a generic make noise. This is an example of, again, polymorphism in action. We've changed the functionality from our dog class or from the animal class to what we want our dog to actually work on or to do specifically. So as an example, if we were to say, in this case, myAnimal, and I can't type today, so let's use IntelliSense to make things much easier. And we said we wanted to use the make noise method. You'll notice that, ooh, what's that going to do for us? Which noise are we going to make? Well, if we were to execute this code, and unfortunately I don't have everything written in here to make this work, so you would actually see all of it functioning correctly, the animal would actually, what we would have here is the animal's sentence would be making that noise. So let's just run a Control F5. Here you see as it builds, animal is making noise, right? If we step back into our animal class, we see that's exactly what's taking place here. However, if in my program I also wrote spot dot make noise. What do we think would happen here? Well, as we execute this code, we can see that the animal makes the noise, but the dog barks. So that's our change in behavior. This is where we're getting that functionality from.
And the thing to note here is that it's the same method call. It's both make noise for the dog and the animal, but the line that's being written to the screen is different based on that polymorphism.
Yep. Yeah, and again, that's the behavioral change, if you will, that allows us to customize what our subclasses or our derived classes have the ability to do. And that's where that functionality gets built into it. So this section here has been a kind of a quick overview of object-oriented programming, where we've discussed the fundamentals of classes, what it means to create a class, what an object is. We've talked about encapsulating data and behavior, and you know how that kind of does data hiding and allows us to kind of control what users do with our classes. We give a demonstration of inheritance, how we can create a base class with specific functionality and have a derived class go through the process of inheriting that functionality and gaining access to the attributes and the behaviors without needing to write that same functionality in our subclass. So again, it's code reuse. It's a way of reducing the amount of code you have to write. And then we looked at changing the behavior of the derived classes through the use of polymorphism and the changing of behaviors and the changing of data types. So that's it for module number 3 on object-oriented programming. And so we hope you'll come back and join us for the next module, Paul. We're going to take a look at demoing web applications.
Sounds like fun.
Sounds like fun.
See you soon.